Hi, my name is Tyler Bach. This is my ME330 line following robot presentation. First, we're going to talk about the structure, then we're going to talk about the code, we're going to talk about the electronics we used, and finally, my unique design. For the structure of the robot, I wanted to make sure I chose the correct material, as that could make the difference in speed and also easy manufacturability. So I chose wood as it is light, it's easy to use, it's modifiable, and it is not brittle. So for the code, I first implemented a simple 2 analog digital system. So if the line was to the left, then the robot would turn to the left. If the line was to the right, then the robot would turn to the right. The only issue with implementing this code is I found that as the robot followed the line, it would oscillate back and forth, as its only 2 instructions were to turn right and left, so thereby making it very slow and not sufficient for competition. I wanted the robot to be able to smoothly follow the line and adjust itself only slightly, which led to me increasing the amount of inputs. So my final code included 2 different types of if statements. One in the sense that if the line was only off by a certain amount, we would turn only slightly. And then if the line was off by a lot, then we would turn much sharper. This smoothed out the line following, and especially in straightaway tests, it led to the robot being a lot more accurate. Now, for the sharper practice test courses, it actually proved to be very viable and would only lead the line slightly, so with some fine-tuning and adjustments, it followed perfectly. For an electronic subsystem, I had 4 QRD sensors mounted on a PCB custom built to detect the line. Now, these 4 QRD sensors, in order to keep track of all the various scenarios, I used binary. So, which was very easy to know that by 0010, in this case, case 2, we would want to turn slightly to the right, as the near right sensor was detecting the line. So, by going down the line of every binary combination and writing the lines of code for the robot's response, I was able to select which ones made sense and which ones didn't make sense and implement them into my final code. So in conclusion, my design implemented 4 unique things. So number 1, I used wood glue. Now, this was not being lazy, but it was because of the thin pieces. I wanted a good surface finish, and I didn't want screws splitting the wood. I put the motor driver underneath the robot, as the slight tilt of my robot allowed me to do so. This reduced the number of wires visible from the top. Third, I implemented case-by-case coding. This was important as it allowed me to logically think through and implement the response of my robot in different scenarios. And finally, I used 4 QRD sensors so I could increase the number of inputs that I had. So what I learned from this semester, I learned that I needed to start my code a lot earlier. That was the limiting factor towards the end and inevitably my downfall in competition. Second, I learned don't be too attached to ideas. There's many things that can be modified and changed on the robot throughout the semester. And finally, despite it being a difficult situation and a difficult semester, I would have done it all again, as it taught me so much about electronics.